Welcome to this lesson. This is Commercial Arithmetic 2, and we look at further problems on compound interest. Specifically, we want to look at the concept of equivalent rates of interest. Now, two rates of interest are said to be equivalent if each rate of interest gives the same accumulated amount over the same period of time with the same principal sum. You have two rates of interest, you have same principal sum, and you are treating the rates of interest over the same period of time, say 1 year. If you end up with the same accumulated amount in each case, then the rates of interest are said to be equivalent. Now, having said that the accumulated amounts are supposed to be equal, it means that the compound interests will also be equal. If each rate of interest given the same principal sum gives the same accumulated amount, it means that the compound interests will also be equal in each case. Suppose we have two rates of interest, R1% per annum compounded annually and another rate of interest R2% per annum compounded every 6 months. Then for R1 and R2 to be equivalent, we determine the accumulated amount in each case. A1 is P into 1 plus R1 over 100 raised to 1 because it is compounded annually, so I want to compare them in 1 year. So in 1 year, this rate of interest is compounded 1, so we will have 1, that's the frequency. So this is the amount under R1% per annum with principal P. Now, with R2% per annum compounded every 6 months, the frequency will be 2 in 1 year. And so we divide R2% by 2, so we shall have here R2 over 200. The principal is the same. Now, if the two rates of interest are equivalent, then it means the two amounts will also be equal. And we have this kind of equation. This is the case when the two rates of interest R1 and R2 are equivalent. So if the amount calculated with the R1% per annum is equivalent to the amount calculated with the R2% per annum, then the two accumulated amounts must be equal. That is only true if R1% per annum is equivalent to R2% per annum. Now, we look at a problem or a question. We look at a question to understand this further. What rate of interest per annum compounded quarterly is equivalent to 10% per annum compounded annually? We have an unknown rate of interest per annum which is compounded quarterly. Quarterly means 4 times a year. And another rate of interest 10% but now compounded annually. Now we let the unknown rate of interest be R, and so the amount will be P into 1 plus R over 400. Over 400 because R% per annum compounded quarterly will mean that in each quarter the rate of interest will be R over 4. So we have R over 400 to the power of 4 because we compound 4 times in a year. Now, the second accumulated amount using 10% per annum will be P into 1 plus 10 over 100 to the power 1. To the power 1 because in 1 year, interest is compounded once. So this is the amount. This is the accumulated amount when we use 10% per annum, compounded annually. And this is the accumulated amount if we use R% per annum compounded quarterly. You can see the principal sums are the same and the period is also the same, except that in 1 year, here we compound 4 times, in 1 year we compound twice. So for the two rates of interest to be equivalent, for R% per annum per compounded quarterly to be equivalent to 10% per annum compounded annually, the A1 and A2 must be equal. The accumulated amounts must be equal, and on that basis we form an equation here. So what are we looking for in this equation? We are supposed to solve for R. The P's will disappear from both sides, and we have this equation here. 1 plus R over 400 to the power 4 equals 1.1. To remove this power 4, we take 4th root of both sides. So 1 plus R over 400 is 4th root of 1.1. And we work it out using our calculator. 1 plus R over 400 is 1.02411. R over 100, we subtract 1 from both sides. So we have R over 400 equals to 0.02411. And our R will be 9.645% per annum. It means 9.645 per annum compounded quarterly will give you the same amount as 10% per annum compounded annually. So 10% per annum compounded annually is equivalent to 9.645% per annum compounded quarterly. So there is no difference if in one financial institution their terms of interest is 9.645% per annum compounded quarterly, and in another bank the rate of interest is 10% per annum compounded annually. There will be no difference if you invest in any of the two banks. That is to say, the two rates of interest are equivalent. We look at another question. What rate of interest per annum compounded every 3 months, that is quarterly, is equivalent to 10% per annum compounded every month? What rate of interest per annum compounded every 3 months is equivalent to 10% per annum compounded every month? Now, let the required rate of interest be R% per annum compounded quarterly. So the quarterly rate will be R over 4. And in 1 year, interest will be compounded 4 times. The number of times interest is compounded will be 4 in 1 year. So the accumulated amount will be P into 1 plus R over 400 to the power 4. So with this rate of interest compounded every 3 months, in 1 year, this is the accumulated amount. Now, the second rate of interest is R% per annum, but compounded every month. So the monthly rate will be 10 over 12%. And that means in 1 year, interest will be compounded 12 times, so our N is 12. So the accumulated amount is P into 1 plus 10 over 1200 to the power 12. Now, for this rate of interest to be equivalent to this one, this amount must be equal to this amount. So we come up with an equation here. And in this equation, we are essentially looking for the value of R. So the P on the left side and the P on the right side will cancel out. And so we have this equation here. We use our calculator to evaluate 1.00833 to the power 12 to get 1.104713. So 1 plus r over 400 to the power 4 is 1.104713. We take the fourth root of both sides, and we have this equation here, this step. Again, use your calculator to get the fourth root of 1.104713, and we have 1 plus r over 400 equals to 1.025209. We subtract 1 from both sides, and here we are. We multiply by 400 both sides, and our r turns out to be 10.08% per annum. What this means? 10.08% per annum compounded every 3 months will be the same as 10% per annum compounded every month. So this is the rate of interest, which is equivalent to 10% per annum compounded monthly. Let me take it through again, the working. Okay, you can follow through once again. You know why we divide by 12? Because interest is compounded every month. So the rate is 10% per annum. So the monthly rate will be 10 over 12. We divide by 12, the annual rate, to get the monthly rate. In this other case, the rate is r% per annum, but compounded every 3 months. So we divide this by 4 to get the quarterly rate. And n equals to 4 means in 1 year, interest is compounded 4 times, but here it is compounded 12 times. Remember, we are comparing the two rates of interest within a period of 1 year. And so we have this amount for the first case scenario, and this amount for the second case scenario. For the two rates of interest to be equivalent, the two accumulated amounts must be equal, and we end up having this one here, this equation. Once again, we drop p from both sides, and we end up having, as we follow through, our r will be 10.08% per annum compounded every 3 months. So that is all with the equivalent rate of interest. Now I would like us to take a typical exam question. This is extracted from KCSE 1995, paper 1, number 17. At the beginning of every year, a man deposited Kenya shillings 10,000 in a financial institution which paid compound interest at a rate of 20% per annum. He stopped further deposits after 3 years. The money remained invested in the financial institution for a further 8 years. How much money did he have at the end of the first 3 years? But B, how much interest did the money generate in the entire period? KCSE 1995, paper 1, number 17. Well, I would like you to try this first before we discuss the solution. Copy it down and try it before we can discuss the working. You can pause the video so that you can try the problem. Pause the video so that you can try the question. Now, I hope you've tried, so let us go through it together. 10,000 was deposited in a financial institution every year. The institution paid an interest rate of 20% per annum. He stopped further deposits after 3 years. So the first question is that how much money did he have at the end of the first 3 years? So 10,000 deposited in the first year remained in the institution or in the account for 3 years. So we compound it at 20% for 3 years. The second 10,000 deposited remained in the account for 2 years, so we compound it at the same rate for 2 years. And the last deposit was 10,000 remained in the account for only 1 year. So we compound it once. So the total amount of money in the account at the end of 3 years, the first 3 years, will be the sum of all these. So you can evaluate this using your calculator. And at the end of 3 years, the money which was in the institution was 43,680. Now, this amount remained in the institution for a further 8 years. So it is reinvested again at the same rate, but now for 8 years. And we can follow through. And finally, we get 187,816. This is the accumulated amount at the end of 8 years. So we are required to find how much interest. So if at the end, the accumulated amount is 187,816, and the sum invested was 30,000. Remember, he deposited 10,000 every year for 3 years. So the interest earned for the entire period will be the final amount, subtract the amount invested, and we end up having an interest of 157,816. Lastly, we have another question extracted from KCSE 2012, paper 2, number 7. Cargo deposited shillings 30,000 in a financial institution that paid simple interest at the rate of 12% per annum. Nekesa deposited the same amount of money as cargo in another financial institution that paid compound interest. After 5 years, they had equal amounts of money in the financial institution. Determine the compound interest rate per annum to 1 decimal place for Nekesa deposits. Once again, you can take this down and pause the video so that you can have time to attempt the question before we discuss the working. Okay, so let us look at the correct working. I hope you have tried. Now, cargo invested at simple interests, 30,000 at 12% for 5 years. So the simple interest is 18,000. So the accumulated amount for cargo is 48,000. Now, Nekesa invested the same amount of money at compound interest. The rate of interest is not known, but compounded once a year for 5 years. So this is the accumulated amount for Nekesa. We are given in the question that at the end of 5 years, they both had the same amount of money in the financial institution. So it means this amount must be equal to 48,000. And on that basis, we have an equation here. And in this equation, we need to solve or find the value of R. So divide both sides by 30,000. We have 1 plus R over 100 to the power 5 equals 1.6. We remove this 5 by taking the fifth root of both sides. And we have this equation here. And you can follow through to find that the rate of interest for Nekesa is 9.856, but to 1 decimal place, we round it to 9.9% per annum. Okay, you can go through again. And to this end, we have come to the end of simple interest and compound interest. In our next lesson, we will introduce the concept of depreciation and appreciation. Till then, thank you very much.